live from an angle of wanting to show, hey, I have a production environment that I'm building. What do I do? What do I need to think about? How do I get started? And so I've got an example to show today, which is captured by this example prod repo that I'm going to use. Here's the code on the left, and I will make that a little bit larger so that we can walk through it. And then I'll talk to what this means. We're going to use this repo and drive the deployment of applications and the governance checks in our pipelines, such that we know when things are passing appropriately and when are they not, and what do you do, and how do you handle that. And so what this repo is comprised of is a variety of things. One, GitHub Actions and workflows. This is my CI/CD pipelines. You're going to see some things commented out for sake of the demo today, because we're going to inject different steps in this process. But we deploy a Kubernetes cluster. We install our cloud native software delivery tool of choice to have that available to us. And then we deploy the software, and we make sure that, one, everything comes online and it's healthy. And then we'll inject some changes. And so from that perspective, what this is meant to signify is, hey, I'm getting started. Here's my production environment, right? This is an example, but here's my production environment. I want to start to configure this Kubernetes cluster with various underlying like infrastructure components. And then I also want to deploy like the web apps, which are going to be the things that get used by my application, get used by my end users in order to, actually provide value to an ecosystem or for your business, et cetera. And so this is capturing kind of like how do we do that deployment. We've got various things in here like manifests for deploying things. We've got validations. These are specific to Lula. And I'll talk to this bit in a second when we talk to how it relates to the OSCAL, and then values for deploying specific applications. And so this is my production environment. What happens here is like, okay, well, for my application, I know I need to do encryption, which means for my implementation, I'm going to use a service mesh that's going to provide for encryption between services, how they talk to each other with mutual TLS. And so I'm going to use Istio. And so I've signified that, hey, I'm now building a production system that uses Istio. And okay, great. Well, now that we've identified that we're starting to integrate systems into this downstream production system, which is what the pipelines will be signifying in this instance, we're deploying to production through pull requests. We're testing things in pull requests, and then once they're approved and merged, they would get basically deployed to that downstream system that can only be accessed by automation and pipelines, right? Not human operators, only the downstream systems. So what we have is Lula is a binary. It's running on my system. A lot of what I'm going to show is also through the pipelines in particular. But Lula, real-time risk transparency through automated validation. We have a variety of commands here that I'm going to show off. And today, kind of one under prototype is a generate functionality. And so I've identified it. I've got a production environment. I've identified I've got a service mesh. And what I want to do is from the very beginning, I want to start tracking my governance against various things. How am I going to do this? Well, first I need a component definition. And so what you're looking at here is a command that generates a component definition, Lula generate a component. It points to a given OSCAL catalog. So this is 853 Rev 5. And so here's my catalog source. This is signifying the controls from that I want to automatically inject and into this component definition, AC3 and AC4, and I want to create this OSCAL component YAML file. Awesome. So we're going to generate that real quick. You'll see a new file over here, and it went and fetched that upstream catalog, went and digested AC3 and AC4 to create the implemented requirements for 853. You can see that here under our source. You can see the remark section has the statements from that catalog. So AC3 enforce approved authorizations for logical access to information and system resources. AC4, similar. These are directly from the catalog. So we've done an automated mapping there to get us off the ground. Provided a description block with a templated in part, which is to talk to how the specified control may be implemented. That would be probably something that you're iterating on and adding to information about your specific implementation. So AC4 here, hey, I'm doing encryption between services by using MTLS, and here's how I verify that. That's all great. And so this is wonderful. We now have our OSCAL. We now want to use this OSCAL to perform automation that will be able to check that our configuration is valid. And so what we'll do is, using the links item, I'm just going to expand this real quick. Using the implemented requirements here for AC4, we're going to inject and reformat this to say, hey, I have some validations. These are specific to Lula that I want to run. And I want to use, and I'm going to use this component definition to house those, the connective tissue between the OSCAL and the controls and the validations that I have stored here. And so you can see this points to a local file, validations, and then validation.yaml. So this right now points to an external file. You could also embed these in your back matter, and I can show an example of that later if people are interested. And so what we've now done is provided a link between AC4 and this validation file, and we've called out the resource fragment here, or the unique validations that we want to run. And so we've got two here. If we look in the validation.yaml file, what we have is two validations. Here's that first unique identifier with a delimiter, and then we have another unique identifier for what is seen here is a Lula validation. So Lula has some identifying information, metadata, and version constraints. And then for sake of brevity, we have two concepts that we comprise these validations on, which are domains. How did you collect your data? And where's that data coming from? And how is it specified? You can see a link here between deployments name and input deployments, and then a provider. And this is your policy engine, essentially. Not something running external, all housed within the Lula binary, but these are utilizing SDKs such that we can use policy such as OPA and the Rego policy language, or Caverno and the Caverno policy language. Currently, there could be room for more in the future, and we've kept this extensible on purpose, such that you take this data and you say, okay, well, what's the policy that I require adherence against in order for this validation to be true, as in passing or not passing, and failing. And so we've got a couple of different ones here, and for showing this off, like one of these is to really validate that everything is online and healthy. Like if I'm going to say Istio meets, my service mesh meets a AC4, it should, one, exist in the deployment environment, but then two, it should also be healthy and online and ready. And so how do we check health? And so we've got a health check here. The other validation that we have here is more global scope and thinking about some of the big picture items. And so what do we do in this cluster? We went and we got all the pods. So this is signifying all namespaces, all the pods in the cluster. And we're going to run this policy against that data, which is going to say that all the pods must be Istio injected. That's what this block means, or they are exempt. And exemptions are applicable in a variety of scenarios. And you would want to document why they are exempt and talk to that. But for sake of that, we've got two validations here that is tied directly back to the component definition. And the component definition will be what Lula ingests in order to perform this validation. So what this means from us here now is we have this OSCAL that we can use. We're going to change our pipelines such that, hey, now we've identified we're deploying the service mesh that we want to deploy the service mesh to production. And so here's the deployment of that deployment step. We'll set up Lula, make sure it's available, and then we're going to perform a validation using that. I'm purposely leaving this commented, and I'll talk to that in a minute. And so with those two items now changed, what I will do is create a branch, and we'll see we have a new file, we have a modified file, which is our pipeline. We'll add that, commit, and we'll say add Istio to prod. And we'll push the new branch. So I'm going to switch back and forth between these views here. Hey, we just pushed a demo branch. This is we want to signify we potentially want to merge demo into main. What would we do here? Adding production apps, bear with me, create this pull request. What that pipeline is going to do is have a governance check. And so this is going to be kicked off here. We can kind of watch this execute. This should only take, but a minute. And so what it's doing is deploying, setting up a Kubernetes cluster, setting up our delivery tool of choice, which is Zarf, which is kind of a standard software delivery tool for the ecosystem I work in particular, because it allows for deploying cloud native apps as well as other applications to the air gap, which is particularly important to a lot of highly secure environments. And so we go ahead and begin to deploy our system here. You can see it's processing. We check the environment. And this is going to show green here. Awesome. Well, what really happened here isn't that we actually performed any pass-fail checks just yet, but we did perform a validation. And so here we deployed Istio. You can see Istio is running. Wonderful. And then perform validation of OSCAL. So we ran the Lula validate command, and I'll talk to the commands in terminology. But we ran it against it, and it said, okay, well, I looked at implemented requirement, and we're just going to say 1608. Awesome. I looked at implemented requirement 1608, which relates to AC3. It was not satisfied. And so why was it not satisfied? Well, we didn't give it anything for Lula to validate. And I think this is very important because Lula can go and run against any OSCAL. But unless you provide it with automated validations, things for which it can produce evidence of satisfied or not satisfied, then it's going to say that, hey, I have no evidence to state that this is actually satisfied, and so I'm going to report it as not satisfied. And that's kind of a current stance that the tool has. But then you see this other one, validating implement requirement, 242F, that relates to our AC4 here, which does have Lula validations. Awesome. And it's saying satisfied. So it ran both of these validations here. They both returned passing, and then everything was happy, right? What we didn't do was say, okay, is it good? Is this good enough or is this bad enough? And in particular, that's an important statement for us. So what we're going to do is we've got this assessment results file here. Where did that just run off to? And I'm going to open that file really quick. It's blocking my prompt. 1 second. And so I'm going to create a new file. Oh, I'm going to copy the file over. We call this assessment results.yaml. Here was the output of Lula. Again, Lula consumes component definitions and produces assessment results files. So you've got this assessment results file now. It's got all the content for the assessment that Lula just performed. 2 findings relating to the controls, right? And so we have AC3, current state, not satisfied. That's expected. AC4, current state satisfied. Here are 2 related observations, and these are the validations that Lula ran. Checking time. And so in that regard, these are the included controls, AC3, AC4, and you can see for each of them, these were the results satisfied and satisfied. And I could do a mapping for you. We're looking to improve upon the transparency of mapping between these things, but these are the related observations. Those are the 2 validations that Lula ran as part of the links. Wonderful. So now we have this assessment results file. And what we can do with this now is use that as our threshold. So earlier, what I did is I kept this commented out. And what I'm going to add here is my threshold. And so the next time that this executes, Lula will perform a new validation using this same workflow that we did previously in the pipeline. It will then consume this assessment results file and compare it to the newest assessment results that was produced. And it'll do an evaluation and say, are you less compliant than you were previously? If the answer is yes to that, then fail the pipeline. Stop everything in its tracks, say, hey, there's something wrong here. You are now less compliant than you were previously. What that will allow us to do is say, okay, well, AC3 wasn't satisfied previously. If on the next run it is not satisfied still, that's okay. Like, we're not expecting it to get to be better. If it is, then we would change our threshold. If it's not, then we're not going to fail on that one in particular. But if AC4 became unsatisfied, that would be a problem. So we've got that one. We've got that changed, the new assessment results file, and the change to our workflow. We'll run that really quick just for fun, but it's not going to produce anything too crazy besides some information in our pipelines. So we'll push that up, and that'll kick off a new pipeline check here for every commit. That's what we talked to with the earlier mention of automated governance. And so I'm gonna let this run. We'll check on this in a second. The fun part of this is then what happens when I want to deploy a new application. I want to deploy an application to my downstream consumers, a web app, right? It could be whatever. It's an app for your business. It's an app for your end users, whoever they may be, and we can start to like show off that workflow. What would that look like? So I've got this commented out here that I kind of mentioned earlier. It's just a standard Nginx web app. You can see the Nginx Docker image. And it's got the some namespace stuff. So here, just deploy my application, right, to this cluster. So Istio will be deployed first, establish my service mesh, and then my web app will be deployed on top of that. So I can have my web app included in the service mesh for my encryption. And then we'll run our validations and make sure everything looks great, right? So before we push that, you can see everything ran just as it did before. We processed, we got to the OSCAL piece, and we said, okay, well, we ran a validation again. Wonderful. But I think we noticed that now that we have a threshold established, we checked. And this is us evaluating the threshold. We have a threshold, and the newest check didn't violate anything against this threshold. So now we have like this set in stone pipeline for, are things working appropriately? Or are they not? Are you more or less compliant? So that'll bring us back to our web app. All we're gonna change is our web app here, and we're gonna deploy that with in our pipeline to say, here's something I want to deploy on that service mesh. We'll go ahead and push that. Awesome. This will kick off yet another pipeline. Bear with me on the pipeline side of the house, because I'll show you could just be running this binary locally if you wanted to for development purposes. And so now set up our cluster, deploy our service mesh. Once our service mesh is deployed, deploy our web app on top of that. That will, in all theory, should Istio inject our web app with the sidecar proxy for MTLS, mutual TLS encryption between various services in the cluster, and that would be one of the quality gates for stating that we are compliant, which is part of what we're trying to establish here. So we treat this as, hey, this is our production environment, and these are how we are deploying apps to that production environment. And we're not manually doing a kubectl deploy. And so we can see, okay, well, I've deployed my application. Everything looks healthy. Okay, awesome. If we come into here now, my web app deployed, and I was, everything was happy. Wonderful. Well, the drift piece that we talked to in the past is still highly relevant. And if you had allowed somebody to say, hey, my web app doesn't work great in the service mesh. If I allowed a human operator to say like, okay, well, what do I need to fix it? I'm just going to take it out of the service mesh to test. And they happen to forget later on to not have it not Istio injected or not included in the service mesh, which you'll see here now is a change that we're injecting. Bad things can happen. And this is where we talk to drift, even with good intent, right? We're saying, hey, Istio injection. I'm just doing this for sake of testing. Does my application work well outside of the mesh? Or, and is it a problem with integrating with the mesh, or some other problem? But if you forget to document that with your compliance, if you forget to exempt it, if you forget to establish other means of mutual TLS, then this impacts your security posture. This impacts your compliance posture, your what you are essentially reporting upstream. So this is kind of signifying, hey, I have potentially done something that is going to impact the end system's state that we are not tracking. If you don't have any other mechanism for deploying to production besides through approved pipelines and through approved GitOps workflows, then this could have just happened without anybody knowing besides the SRE that was trying to test the change. And that would be unfortunate. And so we'll come back to this pull request. Oh no, something has failed. All checks. What happened? We set up our cluster, we deployed the packages in the web apps, and we got to perform validation for OSCAL. And it said, hey, I checked the first one, it was not satisfied. Hey, I checked the second one, it was also not satisfied. I ran my evaluation against my threshold, and I am now less compliant than I was previously. And this is what we're trying to get to, right? This is failed to meet established threshold. This is the process. This is what we want with regards to continuous compliance. This is what we want with regards to automated governance. You are, depending upon how you have things configured, you are not allowed to merge this because the required status checks have not been passed. You are less compliant than you were previously. And what this should do is be like, okay, well, why is that the case? Is it, one of multiple scenarios? Is it something where the validation needs to change? Is this a major version bump in an application? And the validation needs to check new information about how that architecture is built. Totally applicable. Is it something that shouldn't be there, like the web app label and somebody discluding it from the service mesh, something that impacts your compliance? And so you could continue to build on this workflow where, okay, I've got my service mesh, my web app, I want to deploy a logging stack now. And here are the controls applicable to that. I want to deploy a monitoring stack and a policy enforcement engine, et cetera, right? You continue to build on this, and it gives us these quick feedback cycles that allow us to kind of test things in real time. So that was really what I wanted to demo today. The only other thing that I want to mention is that, again, you're not required to run this in your pipelines only. If you want to do your testing locally, right? Lula is a binary that you can retrieve from the releases page. And so you can see 19 hours ago released version 0.21 with a bunch of updates and enhancements, which was pretty exciting on our side of the house. And you could be running all of this locally, right? And so if I've got a cluster deployed, I could be just as well deploying this application to a cluster that's on my local machine in order to do these quick feedback loops. Looks like there might be a issue with my cluster connection, but nonetheless, you could be running validate locally. You could be running evaluate. And so the first step is validate. This produces your assessment results, and then evaluate produces runs the assessment of your latest assessment results against your threshold. Still working out terminology there. And so by all means, if there are better terms to use with regards to the ecosystem, we'd love that feedback. I'd love feedback on anything in particular. Please leave us issues, bugs, and I'll cover that in just a second. But hopefully this was enlightening for our process for how we kind of the automated governance ecosystem has started looking at the problem space. And there's still much more to be solved in automated governance, i.e. attestations. Where do you store those? How are they stored? How are you collecting the data? What is your proofs consistent of? Many more problems to be solved. And so I would love any and all feedback. I think just to close this out so we can hopefully have a little bit of time for Q&A for anybody that has questions. Like a summary, we do this component-driven assessments, gives us these quick feedback loops, right? You get a red X on your pull request if something is not compliant, or if you are less compliant than you were previously. The validation proofs themselves hopefully provide a clear structure for, how do you do this? And this requires a little bit of knowledge about, like, for instance, for OPA provider, knowing how to write Rego if you've done policy as code in another format, such as like Caverno, we support that as well. And we'd like to support other formats in the future as well, like Cedar and Cell. And then where you collect your data from. Right now, pretty focused on Kubernetes for the cloud native space, but I want to, as I'm going to, I guess, allude to, extend that. And so OSCAL native and extensible with the data collection, the policy providers. The data collection piece that I was talking to is I want to extend this out to cloud infrastructure, other infrastructure, vulnerabilities, other key data sources where you can do automated mapping of controls to some data source via a proof. I think that's very important. Reporting in such a way that you can know how compliant you are against a given standard. So take 853, take your system. Is there a way that we could quickly derive you are 40% compliant with 853, 50, 60, et cetera. Those are one of the goals that we're going to work on. And then here in the very near future on our roadmap is continuing to push on this generation piece. I keep clicking. And that one is to call out like the component definition generation that I showed today is still in prototype, but we want to be able to generate templates for a component definition that has what you need. We want to be able to take many component definitions and include them in your assessment plans for running that validation and your SSPs for capturing kind of the system state. We could potentially get to the point where we've, allow for a command, Lula generate SSP, and you could have a template of your SSP with all of the applicable technical controls that gets you to, I don't know, 40% of your SSP in seconds, as opposed to however long it takes. And that's all coalescing on a greater workflow around OSCAL and around any given standard. And then out of Lula and its ability to produce assessment results that you've seen previously, could we derive plan of actions and milestones around that for things that, hey, you are not satisfying these things. Here's a templated out piece of everything that you do not currently satisfy that you could start to add information for your poems around. And so with that last piece, call to action. This is my intent, my team's intent, and my company's intent to donate this to an open source foundation, which means that it's not governed by any single company. And what I really hope that means is people will come and help us work on using OSCAL to, help build out open source foundational models for how to do governance. It could be cloud native. It could be other ecosystems as well. Help us come and grow. There's still a lot we have to learn. And if it's people can open issues, providing us with guidance or new features or tests that we could run against, those are super valuable, as well as just use cases. I'm going to probably open up a template for the repository that is like a use case issue, so that if you have like an intended use case, I want to use it against this standard, but this isn't working for me in particular. How could we solve that? Any insights that could be provided through that, through issues, I think would be helpful for the community at large. So yeah, with that, appreciate everyone letting me talk your ears off for almost an hour. Any questions?